Hi everyone, it's Mrs. Schmidt, and I'm here today to talk to you about how to represent a remainder without using the R. Now I know a lot of you are thinking, why do I have to change? Why can't I use the R? I like the R. Why do I have to change? Well, don't worry. You're already going to use something that you already know pretty well, and it's a much more mathematical and descriptive way than using the R. So let's get started. Let's go to our first example. All right. We're going to start with a question that the very first time you ever learned how to do division, this is kind of how you started. So let me grab my color. All right, 12 divided by 5. So the very first time you ever started doing division, you probably had some manipulatives and your teacher gave you 12 of them. So I'm going to give you 12 of them on the screen right now. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then your teacher said, all right, how many groups of 5 can you make with your 12 coins or your 12 counters? So you're like, all right, I got this. I'm going to just group them into groups of 5. How many can I make? 1, 2, 3, 4, 5. I made a group. There's one group. All right, 1, 2, 3, 4, 5. I made another group and I've got 2 left over. So you're like, okay, I can make 2 groups. And then I have 2 left over. So that's kind of where that remainder 2 comes from, the R2. It's the leftover stuff that you didn't have enough to make a group of 5, and so it's just left over. So let's see how this has looked for you now that you know how to do basic and long division. You have said, all right, well, I'm going to take my 12 and I'm going to divide each digit by 5. So can 5 go into 1? No. But can 5 go into the whole thing, 12? Yes, it can. How many times can 5 go into 12 without going over? Well, it goes in 2 times. So 2 times that 5 creates a 10. So you subtract what you created and you have 2 left over with nothing left to bring down. So in the past, you've said, all right, 5 can go into 12 2 times, but then I'm going to have 2 remaining that from my 12 that I just really couldn't make another group of 5 with. All right, so now I'm going to use fraction circles, and I know you're very familiar with fraction circles to demonstrate what this would look like with fraction circles. So let's use yellow. Now bear with me. I'm going to try and divide these up and it's not going to be perfect, but you get it. So I know I need to make groups of 5. So I'm going to divide my fraction circles into 5s. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that last one's really bad, but just hang in there with me. All right, so we'll grab our green again, and let's model this. How much did you have? You had 12, okay? And how many groups of 5 can you make? Well, let's shade in 12 slices. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so here you can see you were able to create 2 entire groups of 5, and then you had 2 left over that you couldn't quite make that entire group of 5. So I want you to look at your fraction circles for a minute and see if there's another way that you can express 2 remainder 2 in a more mathematical way. If I had given you just the picture of these fraction circles and I said, what number does this represent? What would you have said? Well, are you able to make any holes? Did you create any holes? Yeah, you did. How many did you create? Well, this circle is entirely filled in, and this circle is entirely filled in. So you created 2 wholes. All right, well, what would you call this? If you were looking at fraction circles, would you ever call it, oh, well, that's 2R2? No, you wouldn't call it that. You would say you've created 2 wholes and you have 2/5 remaining. You have 2 pieces left out of the 5 you need to create a whole. Wait a second. So I went from going to 2R2 to 2 2/5. This is how you are now going to deal with the R. You're not going to use an R. You're going to express it as a fraction because you have some pieces remaining that you couldn't quite create another whole with. And when you express it as a fraction, it's much more descriptive in math than just putting an R. Because I don't know, when you just use the R, I don't know how many pieces did you need to create the next whole. Are you close to getting another whole? Are you not even close at all? So if you can express it as a fraction, that tells the reader who's looking at your math just how much that quantity really is. So something you need to remember, where did we get this 2? What is the 2? The 2 was the remainder. What did we put the 2 over? We put the 2 over the divisor. All right, so you're always going to express it as a fraction with the remainder over the divisor. So let's take a look over here. 2 was our remainder. 5 was our divisor. 5 was the quantity you needed to create another group. So let's try a couple examples together. All right, let's do 216 divided by 25. And as you know, the first quantity is always the quantity that goes under your division roof. All right, so 216 divided by 25. All right, so 25 can't go into 2. Oh, I can't go into 21. Can it go into 216? Yes. I'm going to have to use a really good estimate to help myself get there. Well, okay, I know that there's 4 25s in 100. I have 200s. So if there's 4 in 100, there's got to be 8 in 200. All right, so I'm going to put an 8. I had to go all the way out to 200, so I'm going to put an 8 up here. What do you get when you do 8 times 25? 200. How many do I have left over? 216 minus 200 is 16. Do I have any more place values to bring down? I don't. Could I have made another 25? I can't. So instead of just putting 8R16, I'm going to use a fraction so my reader can understand how close I was to making that next whole number. So I'm going to say I made 8 entire wholes, and then I had 16 out of the 25 needed to create my next whole number. Therefore, I'm expressing my answer as a fraction with the remainder on top and the divisor as my denominator. All right, let's try another one. 487 divided by 12. So 487 goes under my division bar, divided by 12. 12 can't go into 4. 12 can go into 48, and it can go in 4 times. And I'm excited because that makes an even 48. So 4 times 12 is 48. Yay, nothing left over. Let's bring down my next place value. It is 7. Oh, no, 12 can't go into 7. Well, sometimes this is where a student might make a mistake, and they might say, 12 goes into 487 4 and 7/12 times. But wait a second. I did not record an answer above this place value. So since 12 can't go into 7, I need to record that. 12 goes into 7 0 times. 0 times 12 is 0. And now you see I recorded an answer above my place values, and I have a remainder, nothing else to bring down. So I'm going to say 12 goes into 487 40 times, and I had 7 remaining out of the 12 I needed to create my next whole number. So my answer is 40 and 7/12. All right, guys, I hope that was helpful. I hope you feel comfortable leaving the R in the past and using a more descriptive mathematical way to express your remainder, putting the remainder on top over the divisor, telling your reader just how close you were to making that next whole number. Have a great day.